Alright guys, in this session we're going to talk about a specific protective equipment in the field of electricity. More precisely, we use this equipment for protecting the single-phase and three-phase motors. Now this equipment is called bimetal relay or overload relay. Now, first and foremost, let's see how exactly this relay works. Before we start, let's answer a question real quick. What exactly overload is? Well, when we connect our three-phase motor to three-phase lines, normally an incoming electrical current would be created, all right? Like, for example, the motor could start getting, like 10 amperes of electrical current. Now, during so, a problem might appear in the motor. For example, we might face a problem with the motor's bearing or even an overload on the motor's axis, for example, And, well, basically, as a result of some problem, the electrical current would be increased from 10 amperes, let's say, to 16. And overall, this exact phenomenon is what we call an overload. And in case we don't control it, it would be quite problematic. Like, for example, it might harm the coil in the motor. Now, let's take a look at some situations in which overload could actually happen. Well, in the first situation, the connection that we need for the motor might not be done correctly. We call this incorrect coupling, and you can see it here as well. In the next situation, an extra load would be added to the motor's axis or the motor's shaft, as you can see here. I mean, more specifically, an additional load more than the motor's actual power. And then lastly, in the third situation, we might face a problem with motor's bearing, which is actually noted here as bearing failure, okay? And overall, these three situations could cause our system to simply overload, all right? Now, let's move on and, talk in more detail, guys. Okay, take a look at the image here. Assume that we have two pieces, one iron, the other one brass, and they are connected together. And an electrical current is moving or passing through them. Now, when the mentioned electrical current increases, the electrical current that is moving through this piece increases, first and foremost, the temperature of these two pieces would be increased. And, the created high temperature would causes the contact to bend, just as you can see in the image, okay? And as a result of this bending, the electrical current would be cut off. It would stop completely. Now, guys, let's go ahead and see how exactly we can protect our motors in case of overloading. Okay, let me change the slide. Okay, let's see what exactly we got here. In the normal situation, the electrical current would be 10 amperes. And again, in the normal situation, we have three of these contacts set in the path of our electrical current, okay? Now, let's say the overload has happened. The electrical current has increased from 10 amperes to 16. And as I said, because of the high temperature that would be created, the first thing that we would detect would be the bending in the contacts. And once more, as I mentioned a few seconds ago, when this bending happens, the electrical current would be disrupted. It would be cut off. And obviously the motor would stop working. It would be turned off. Now, let me move to the next slide before we continue. Now, bimetal relay or overload relay. First off, this would be its interior structure. More precisely, we have three contacts set in between the terminals L1, T1, L2, T2, and L3, T3. Now, guys, through a specific mechanism, these contacts are being connected to a couple of more contacts here. One of them is normally opened, the other one is normally closed. Now, we have some specifying numbers here as well. We have 97, 98, 95, 96. And again, guys, this is important. Don't forget this. We have two types of contacts. One of them, more precisely, this one is normally open, and the other one is normally closed. Now, when overloading starts to happen, when the bending in the contacts would start shaping up, the normally open contact, this one, would be closed, and the other one would act in reverse. The normally closed one would be opened. All right. Let's move on. Now, how exactly they work in a circuit? Well, normally the electrical current, more specifically 10 amperes of electrical current, turns on or starts the motor. And after that, we actually need to set an equipment here called a signal lamp. Then there's a phase line here that is actually connected to this contact here, 97, and 98 is connected to the signal lamp. And the other side of the signal lamp is being connected to the no line. Now, in the normal situation, the signal lamp would actually be turned off. And immediately after overloading would be started, immediately after this specific bending in the contacts would be started, the electrical current would be cut off and the motor would be turned off. And as a result, the normally open contact would be closed down, 97 and 98, and the signal lamp would be turned on, which actually is a warning which tells us that the motor is overloading. All right? And by the way, guys, normally there's a yellow color to these signal lines, and well, we can usually find them set on the doors of our electrical panels. Okay, let's move on. Okay, everyone, so far we successfully found out how exactly a bimetal relay, aka an overload relay, would function. Like, more specifically, we said that we have three terminal sets up here, talking about L1, L2, and L3 more precisely. And then on the other side, or down here, we have T1, T2, and T3. Then we said we have a couple of more terminals set here. 97, 98, 95, 96. We said 97 and 98 are normally open. And the other two, 95 and 96 are normal closed terminals. Okay? And well, by the way, guys, remember, we usually use these terminals in control circuits. Okay, moving on to the next slide, Again, we're going to see a clip. Okay, let me play it out. What we have here, up here, we have L1, L2, and L3. And here we got T1, T2, and T3. And then here we got 95, 96, and also 97, 98. Alright, now let's take a look at how we can connect a bimetal to a contactor. Well, let's take a look at the schematics that we have here. L1 would be connected to T1, L2 to T2, and L3 to T3. Right, and also let me play a video on this as well. So basically, guys, the T terminals set in the contactor would open, and then we can set the bimetal and use some screws to connect it completely. Again, these would be the L terminals, and down here we have the T terminals. Okay, guys, let's move on to, I guess, the last slide of ours. At the end, we're going to take a look at the symbols that we have for bimetal relays or, well, overload relays. As always, we have two versions, the IEC symbol. And by the way, guys, this here represents the power circuit, and this part represents the control circuit. And well, obviously, we have the NAMA symbol as well. And again, we have the power circuit as well as the control circuit.